This question is from the GATE 2020 Ee paper. This is question 25, where we are given a MOS capacitor with voltage applied between the gate and body contacts and asked to find out what the total charge is contained within the dashed box, that is the Gaussian surface. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So in this question, which is question 25, we are given a cross section of a metal oxide semiconductor structure as shown below. We have a gate, we have silicon dioxide, silicon, and a body. The gate and the body actually represent conducting contacts to the gate and the body. So the idea is that this is conducting, and silicon, which is a semiconductor, and semiconductor can also be thought to be conducting, but silicon dioxide is an insulator. So the structure is two conducting plates separated by an insulator, which is a capacitor. So this is a valid construction of a capacitor, and we are provided a dashed box around it, which basically means it's a Gaussian surface that is surrounding the capacitor. We are asked to find out if during the process of charging the capacitor to a bias of 3 volts, the charge that is inside the silicon dioxide layer alone is measured to be plus Q, that is after the process of charging. What is the total charge contained within the dashed box upon the application of the bias, that is upon the application of the plus 3 volt bias after it has been charged up. So this is basically the circuit that they're asking us to analyze. That thing is a valid capacitor, so I'm going to put it as a capacitance C, and if we assume that the switch closes at t equal to 0, it gets charged up to 3 volt. Now the only thing that we need to remember here is KCL. That is, if you have a node or a branch, if you in a circuit, if you have an element in a circuit that is connected to these terminals as such, and each terminal has a current, let's say that's I1, I2, I3 going into it, KCL tells us that summation of I equal to 1 to 3 in this case is equal to 0, and this generalizes of course to as many terminals that you have, right? In the lumped case, this is the lumped model. But what exactly does this state? If Q is the charge that is on that element, and the currents, that means that the total current entering that element is the rate at which that Q changes. And saying that the total current is equal to 0 just means to say that dq by dt, that is the rate at which the total charge in that element changes, is 0, which is to say that Q does not change. If the derivative of something is 0, it is a constant. That is, Q does not change, Q is a constant, right? So all that's left to remark here is that this is also having two terminals and it's connected. So therefore the total charge inside, so clearly this pink represents the dashed box in our problem, right? And that the total charge inside the dashed box, Q does not change, right? Does not change. Now all that is left is to remark that initially the capacitor is uncharged, and we can take it that Q is equal to 0 initially. Since this Q does not change, we get that Q is equal to 0 finally, that is after the application of the bias, right? So yeah, as this does not change, right? So therefore we get that the answer is 0, and since they are asking us the answer as a multiple of Q, we can just say 0 into Q, and so therefore the answer is 0.